Hi, meteorologist Jennifer Perez, and this is What's Up with the Weather. It's the second installment of the series. And in this one, we're going to talk about how precipitation forms, how it develops, and the types of precipitation and how that develops. First, we started off with how the weather even begins with solar energy cooling and condensing and forming into clouds. Now we're going to skip towards precipitation, but first we have to talk about the atmosphere, okay? The atmosphere consists of several different layers vertically up within the atmosphere, from the troposphere, which is about 10 kilometers above the ground surface, all the way to the exosphere, which is about 600 kilometers above the ground surface. And you kind of want to think about this as a bubble that surrounds the earth and it protects the earth. Now, most weather kind of tends to occur right within the troposphere, in the lowest levels within the atmosphere. That's where most weather occurs. And as meteorologists, we look at that layer and we kind of subdivide it into different layers. And each layer has different temperature and moisture characteristics, which is why it's important in eventually seeing the type of precipitation that we could potentially see within a given system. So this is how it breaks down. We look at different types of pressure levels close to the ground surface, starting it off at the 850 millibar level, which is about 5,000 feet above the ground, all the way up to about 300 millibars. That's at 30,000 feet above the ground surface. That's usually where planes tend to fly. That is also known as the jet stream. So we categorize these as the lower, the mid, and the upper levels. These are the levels that we look at. Again, each level has different types of characteristics. For example, the upper level flow, you've probably heard that before, right? That's what is known as the jet stream, okay? And the jet stream is basically a river of fast-flowing air, and it helps steer a system in a given direction, okay? So it's what helps move it into a specific area. So we really look at the upper levels for that, but each of these levels, again, have different temperature and moisture characteristics. So as precipitation falls vertically from up high in the atmosphere towards the ground surface, it encounters these different types of layers, all of which, again, have different temperature and moisture content. And as it falls, it encounters that air, and it could potentially change the type of precip it ends up being once it reaches the ground's surface. So that's why it's important for us to look at those different levels, okay? But how it forms, how precipitation forms, well, there are two different methods essentially. The first one is in cold clouds. Now, this is a common process that happens in the mid-latitudes where we live. Basically, you have to have a cold cloud. That cloud has to at least be, or the top of it has to at least be 14 degrees below Fahrenheit for nuclei to develop, activate, and eventually turn into ice crystals, okay? So stay with me here. 14 below temperature at the top of the cloud. Nuclei develops. Nuclei. Okay, well, what's a nuclei? So a nuclei develops on tiny little particles that are suspended within the air and in the atmosphere. You can't really see it, but those particles could be anything from dust, sand, ash, or any other type of aerosol. And so those little tiny particles are suspended within the air. Once water vapor rises, because warm air rises and it cools and it condenses, right, into water vapor, eventually it condenses on top of those little nuclei, those little particles, okay? So for water vapor to condense, we need those little particles within the air for that to happen. So once it develops, it activates within this cold cloud top and it turns into an ice crystal, right? So then begins the process that's called the Bergeron process. In this process, we have to have a combination of water vapor, liquid droplets, and ice crystals all combined together within this cloud. So as it develops, as that ice crystal develops, it continues to grow into a snowflake. So all of our precip initially starts within this process, and within cold clouds, starts off as an ice crystal and snowflakes. And then again, as it falls, it could potentially change. So we started off with the ice crystal, and those ice crystals continued to grow and form into a snowflake at the expense of liquid droplets and water vapor that are also within that cloud combined with those ice crystals. So what that means is those ice crystals that are formed, they take the energy and the moisture away from liquid droplets and water vapor. It takes that moisture and that energy away, and it combines it into the ice crystal, and therefore the ice crystal grows bigger and bigger into a snowflake. So once that snowflake grows large enough, eventually it starts to precipitate and fall towards the Earth's surface. And then again, depending on the characteristics within the air, will eventually lead to whether or not it ends up being a snowflake at the ground or if we end up seeing some rain. Now, the second process in how precipitation forms is within warm clouds, okay? This is something that is very typical in the tropics, okay? Warm temperatures within the cloud. You started off, instead of ice crystals, you have nuclei, so you do have those little tiny particles within the air. Sand, dust, ash, aerosols of some sort, tiny little particles for water vapor to condense on. Okay, and then once it condenses on them, it continues to grow, and you eventually get giant condensation nuclei. So these giant particles and droplets within a large cloud, within a vertically large cloud, okay? So the larger the cloud, the better it is for those condensation nuclei or droplets to continue to grow. Why? Well, because you have enough space for those droplets to kind of go up and down and bounce around here and there and continue to grow in size. Again, that's something that's typical within the tropics, generally just all, for the most part, liquid droplets. Eventually, it continues to bounce around within the cloud, and they bounce off of each other in a process that's called collision and coalescence. It gets large enough to eventually precipitate out. The largest size generally is right around 5 millimeters. When it gets to that size, it becomes just too big, and the water droplet becomes too heavy. Once that happens, it falls and it precipitates towards the Earth's surface. As it falls within the cloud, it encounters wind that's coming vertically from the ground surface towards the droplet. So there's friction that happens, and that big droplet eventually falls and breaks apart because of the friction from the wind that it encounters as it's falling towards the ground. So while it might be a big droplet, it will eventually reach the ground as tiny, small water droplets, okay? So again, the max size is right around 5 millimeters. Now that we've covered how precipitation forms, let's talk about types of precipitation. Remember how I said earlier how it's so important to look at the different layers within the atmosphere because each one has different characteristics as far as moisture and temperature? That affects the type of precipitation we see out on the surface at the ground level. So if you generally have a warm layer of air vertically within the atmosphere from the ground towards, say, the middle and upper portions of the atmosphere, you eventually just end up with rain. And then if it's generally just cold, especially less than 32 degrees Fahrenheit, for the most part, it's snow. And then in between, that's where it kind of gets a little iffy and it gets tricky. You really have to pay attention to what we're seeing in the details because you could end up with freezing rain or sleet. So here's a vertical look at what I'm talking about those layers. We start off with, we're going to talk about rain. That's the first one we're going to talk about. We start off with snowflakes. Remember how I said usually in our neck of the woods, in the mid-latitudes, our precipitation starts off as ice crystals and snow. Within a cold cloud layer. So the cold air at the top of the cloud, again, 14 below in Fahrenheit, for the ice crystals to develop at the top of that cloud, right? Starts off as snowflakes and ice crystals, and it encounters a deep layer of warm air. As that snowflake drops through that deep layer of warm air, it completely melts. Total melting happens, and that ends up in just being rain as it reaches the ground's surface within that case. The second case is freezing rain. It starts off again as ice crystals and snowflakes within a cold layer at the top of the cloud. As it falls, it encounters a layer of warm air, and it partially or almost completely melts, that is, right? Completely melts. And then at the surface, there's a small, shallow layer of cold air. Once that water droplet encounters that cold layer of air close to the Earth's surface, that water droplet becomes super cooled. Cool enough for when it lands on the Earth's surface and with the cold air in place, it eventually freezes. And then the third type is sleet. We start off, again, with ice crystals and snowflakes at the top of the cloud, at the top of the atmosphere, the layer. That ice crystal and snowflake falls and it encounters a shallow layer of warm air. Within it, it starts to melt. It partially melts. It does not completely melt, partially melts. As that partially melted snowflake continues to fall, then it falls through a deeper layer of cold air where it refreezes into little ice pellets, otherwise known as sleet, once it reaches the ground's surface. And then, of course, we have snow. We started off with those ice crystals and the snowflakes at the top of the cloud, and then it falls through a cold layer of air vertically from the upper towards the middle to the lower levels of the atmosphere and towards the ground surface. And with that setup, it just generally ends up being snow. But again, moisture and temperature, the content of the amount of moisture within this layer and the temperatures, could vary a degree or two. All of those little tiny factors will affect the type of snow that you could even see at the ground surface, whether or not that's going to be more of a dry, packy snow or a wet, packy snow or a dry snow that ends up reaching the surface. That's why it's so important, again, to analyze those different types of levels. All right, a cool little mini experiment to kind of get you in the spirit of weather and rain. You can make your own little rain gauge. All you need is to have a 2-liter bottle. So generally, just if you have a soda bottle lying around, have that. You want to have some masking tape and a ruler. You want to cut off the top of that 2-liter soda bottle. And then what you'll do is you will take the ruler and you will mark about 6 inches or 5 inches on that masking tape with your ruler, and take the masking tape and then just put it pretty much on the side of the soda bottle. You flip the lid upside down or inside into the bottle. And what you want to do is, if you want to prevent it from tipping over, you could put some rocks in it or adhere it to somewhere outdoors, screw it onto a post or something. That way, when the rain falls, it falls through the little funnel there, and you can actually measure it, okay? But again, you want to kind of keep it in place somewhere sturdy so it doesn't get blown over or anything like that. So that does it for precipitation types and precipitation formation.